As I was just saying, Sina is joining us from Swobbie to talk about, how do we approach a critical mass of micromobility users and the importance of battery swapping to, as she's described it, uplift micromobility to the next level, which I think is a nice turn of phrase. We'll be talking about battery swapping infrastructure in Europe and all around the world. Sina, thank you for being here. So excited to have you.
Thanks so much, Luke. Hi, everyone. It's great to be here. Calling in from very cold and very dark Oslo, Norway. So I'm very jealous of the folks who are sitting in California. I hope everyone's fine with the flooding. Indeed, I work for Swobbie as head of expansion. And for those of you who don't know us, Swobbie is a Berlin-based startup, and we build battery swapping stations for swappable batteries in micromobility. And today we're going to talk about the tipping point of micromobility and what is needed to reach it. We're also going to be talking about how battery swapping is a network effects business. But to start, I want to take some time to reflect on where we are standing right now, the start of the year 2023. We see that there's a critical mass of adopters of micromobility, and at the same time, there's increasing regulatory pressure and increasing pressure for micromobility companies to become profitable. So that's the context in which we're in at the moment. And since we're talking about tipping points, I want to start with a generic definition of tipping point. So what do we mean when we talk about a tipping point? We're talking about the moment of critical mass, the threshold, or the boiling point. So the point in time when a product, a service, or a trend crosses a threshold, trips, and basically spreads like a wildfire. And now what I want to add to this definition is that to reach tipping points, we don't need only a critical mass of adopters, of users, but we also need a profitable business model that's sustainable on the long term. And when we look at which factors contribute to reaching tipping points, network effects is one of the candidates. It's a term that's vastly used, but what does it actually mean? Network effects are occurring in contexts where a product or a service offers increasing benefits the more users it has. So network effects ask, okay, does customer 200 have a better experience than customer 100? In other words, does every new joining user have a better experience than the previous one? There are 5 types of network effects that you can look at, broadly speaking. The first one is direct network effects. And that happens when an increase in usage leads to a direct increase in value. This is something we can observe with WhatsApp or Facebook, where every one of our family members or friends who joins will make the product more useful for us, more valuable for us as a user. In indirect network effects, we have an increase in usage that will encourage the consumption of a complementary product. So for example, with Android, iOS, or Windows, all these encourage software developers to develop new applications on top of that original product, which in turn will increase the value of the original product. Then we have two-sided network effects. That's probably the one that's most known to us, where the increase in usage by one specific set of users leads to an increase in value for a different set of complementary users. So Airbnb is a great example, or let's take Uber, where every new person that wants to go from A to B on Uber will make the product more valuable for the other users that are already on the platform, the ones offering rides. And then we have local network effects, where a small subset of users that are bound together in the same location, and their increase in usage will increase the value of a connected user. Here we can look at the live social media feed Yodel, which offers a location-based platform for users in the same area to share live news, jokes, events, or the like. Of course, you can also take any dating app that's location-based, like Tinder or Bumble, as great examples of local network effects. And finally, we have standard-based network effects, where the use of one technology product will encourage the use of compatible products. So looking at Microsoft's Office suite, for example, with that, Microsoft was able to create the dominant document file format and made it into the standard until it was disrupted by Google Docs. But that's a great example. Same goes for the USB connector. Both these have led to increased standardization and increased compatibility. So how do we tell that a product has network effects? There's a few indicators, and these are not exhaustive. It's also not the case that you have to answer yes for every one of those questions to be able to say a product has a network effect. But they're quite useful when we try to understand how strong a network effect is. So what you can ask is, does the product have a network to distribute itself? Does it connect people with each other, whether that be for collaboration, for communication, or any other purpose? And does its ability to attract new users or to monetize, to become sticky, get even stronger as the network grows larger? So for this presentation, we're going to limit our scope and look at network effects through battery swapping infrastructure. But of course, there are many different many different network effects that are emerging or have already emerged through different technologies in micromobility. I was just listening to Ubik's presentation about the street crowd, which connects people who want to carry out tasks to companies who want to offer these tasks to them on the platform. So for example, the relocation of a vehicle or charging of a vehicle. And this then allows mobility companies to reduce their employee cost and reduce their need to purchase equipment. I think that's fantastic. And that's a great example of a network effect as well. There's many more, but even just generally looking at micromobility from a macro perspective, it's quite impressive how quickly users have adopted these new technologies. It's very natural for us to now use our smartphones to call an Uber or a Lyft or to unlock an electric scooter within seconds. So there's a lot going on, but for now, we're just going to zoom in on one aspect of network effects, and that's the one brought by battery swapping and by the infrastructure that's required to support large-scale battery swapping. So what role does battery swapping play in micromobility? Right. All of us know micromobility, those little electric scooters and bikes and mopeds, they're everywhere. But what most of us probably don't know is the big problem of micromobility, the cost of operations. For every scooter ride, the necessary cost for charging operations is more than 40% of the total revenue. Just let that sink in. For a single scooter ride, 40% of the revenue needs to be used to cover the operational cost of charging. Why is that so? Today, every day, empty batteries need to be collected in the cities to then be taken to warehouses that are often far away, where they are swapped, charged, and then distributed and redeployed in the city. Our solution to this is the Swobbie network, a network of battery swapping stations around town where users can swap their batteries on the go. And on top of that, we also have a software solution with an open API that offers insights into battery health and swapping operations. So for the users of the network, the added value is in, first of all, the cost reductions by making the trip to swap batteries shorter, safety due to battery and charging monitoring. Then we're also able to increase their uptime because we're reducing the long waiting times of traditional charging. Users are able to remove their range anxiety because the network offers fully charged batteries wherever they're needed. And finally, they're able to gain access to fast access to indoors, outdoors locations in cities, including the setup, the operations, and the maintenance of the station network. So that's all very nice, right? But which type of network effects can we actually create with this network of battery swapping stations? And here I want to start with coverage. The more users we have in an area, the more battery swapping stations we can put up. And the shorter the trip will be for the user to the next possible battery swap. So that's a very local effect. And here, this is actually the most important one to consider when we talk about profitability, because the more users we have, the cheaper the individual battery swap will be, and the faster we're able to reach this tipping point. Then next up, something that we emphasize in everything we do at Swobbie is multi-modularity and an open systems approach. That means that we're not just compatible with one battery type, but with many different ones, and looking to expand that as well. So that's our contribution to standardization and compatibility. And last, by gathering battery data, we are able to improve battery handling through the first life, second life, and end of life. The more users we have on the network, the more data can be collected, and that will help us as Swobbie to adequately predict swapping patterns and battery lifetime. But then indirectly, also this data can be used by other companies who work on improving the transition to second life applications and the transition to recycling. So those are the network effects that we can create through battery swapping infrastructure. But what is needed to create those network effects? For us, it starts with building an atomic network. And that's the smallest possible network that is stable on its own and can grow on its own. Starting out from one user base with a hard problem. And for us, this user base are logistics companies and micromobility operators who want to reduce their operational costs of charging. When that's done, we're working on getting the distribution right. It's fantastic to have a great product, but if we can't distribute it, it's of course of very little value. So here it's key for us to set up stations quickly and in high quality locations that are central, accessible, and nice to go to for the users of the network. One aspect to stress here as well is overcrowding. We don't want to have too many users on the network. That would mean that there are not enough batteries available. So that's really something that is key to getting right for winning in this game. When 1 and 2 are covered, the network can grow city by city, country by country. So where are we now on this journey? And where are we going as Swobbie? Today we are compatible with 30 vehicles. We have more than 70 stations live. Most of them are in Berlin, where we have our most dense network and where we're building this atomic network. But we're also doing projects in other cities and countries to test out where the appetite for battery swapping is the greatest. And moving forward, we're going to expand internationally. We're going to further work on standardization. There we're part of the Swappable Batteries Motorcycle Consortium with Piaggio, Honda, Yamaha, and KTM. And we're going to integrate additional batteries to improve our compatibility and coverage. So I want to invite you to come join us in creating those network effects through battery swapping infrastructure to reach this tipping point in micromobility. And if you want to find out more, definitely get in touch. Looking forward to your questions, and thank you.
That was great. Thank you so much, Sina. I feel like I learned a great deal in a very condensed amount of time. That was a micromobility presentation, and it was incredibly informative. Thank you for your time and insights. I see some questions coming in. I'd like to leave time for them. Maybe I could feed you a question or two, and then I've got to jump to the next session, but you continue all to hang out here, ask Sina questions. She's graciously offered her time to us to take any questions you may have about charging, battery swapping, network effects, and broadly speaking, the tipping point of micromobility. So first question before I jump is from Sergey. Sergey asks, how heavy can the batteries be? Might drastically impact the feasibility of swapping batteries by users themselves.
Yeah, thanks, Nathan. It's a great question. So indeed, there are some batteries that are theoretically swappable, but they're too heavy. And having to lift them up, right, it's a problem for many users who live in high buildings without an elevator, and makes all the need for battery swapping stations. But also we have a limitation there, and what we take as a rule of thumb is 15 kilograms.
Someone will
15 kilograms as really the max of what a swappable battery should be weighing. Is something that I think will be important also not just in micromobility, but also if you look into marine, where they're using now many different batteries so that they're actually swappable.
Wow, there's a flood of questions coming in now. I'm going to pass one more on to you, and then I'm going to depart, but please continue to hang out and take more. Andrew Lott asks, how do you see the challenges in operational management to battery swap?
Yeah, good question. So I think what's key here, if you look at the operations, is obviously it costs money to put out the product. We're not a software company where the replication and distribution of the product is nearly for free, but we're setting up physical infrastructure out in the streets. So there's a cost with putting up a station. And in operational management with battery swap, what you want to get is a very high utilization of the station. So the demand analysis is a very crucial step in planning where those stations should be, with which battery slots they should be equipped, and who has which roles and rights to make reservations and use the station. So there we have two models actually. We have public Swobbie stations that are used by all of our customers who rent batteries. So nobody actually is owning the batteries except Swobbie, and the batteries are constantly changing owner in a way, user. And then we have private stations that are dedicated to the operations of just one of our customers. And there it's a bit easier to plan because you're just working with the data of one user group and not many different ones, if that answers your question. Then there's a question from Meredith that I'll take. How are you managing the time to charge the batteries within your network? From my understanding, many e-bike batteries take up to 4 to 5 hours to charge. Yeah, that's pretty accurate. It's like 3 to 4 hours for the batteries that we have in our system. Here it actually goes back to a previous question of managing operations. You want to arrange your shifts of employees who are doing the swapping in a way that they're able to go around the whole time, collecting empty batteries and bringing them to a Swobbie station nearby. And of course, there is a waiting time with charging there as well. So they need to go to the next Swobbie station. And we have a routing algorithm for that will just send you to the next station through our app where you'll find available batteries. Then there's a question from Alexandre. How do you see the hardware and software evolution of batteries overall? I think there is, maybe we can make a distinction between the vehicle categories. If you look at the kick scooter market, there's more consolidation. We have a few players that are really dominating the sharing market there. That's Okai and Segway. Whereas in the e-bike market, right, there's so much development with e-bike batteries, both in hardware and software. I think on the software part, it's more convergent, right? Many batteries are using the same protocols, so that makes it easier. But in terms of form factors, there's way more diversity, and that makes creating the infrastructure also harder. Then there's another question about the success rate of the swap experience, at what percentage? So I assume with success rate, you mean like a successfully conducted swap with someone inserting the empty battery and getting the battery out. Yes. So here we're actually very close. I think there's like in 95% of the cases, it goes well. And then in the other 5%, it will show you a message like, please insert the battery again if it's not properly connected. But usually we don't have any problems with that. Then David, I understand the EU is currently redrawing the law regarding lithium-ion batteries. Will this affect the battery swapping industry? I think this is a question about safety as well. So I'm not sure which law specifically you're talking about, but regarding safety, what I can say is there is not really much regulation yet regarding the charging of lithium-ion batteries in unmonitored areas like warehouses or even residential buildings. So I think as we are seeing an increase in the battery population that's out there, we're going to see an increase in incidents. I think that's stresses the importance of monitoring the charging. Like whoever builds up this battery swapping network, the monitoring will be the most important one to prevent batteries from heating up uncontrolled or even worse, burning. I hope this answered the question. Then that's the last question. How do you compete with e-bike manufacturers moving towards internal batteries? I think, I love the Fun Move bikes with the internal battery. Like from a design point of view, I think it's great. But of course, if you have to have the vehicle on the road 24/7 for high utilization, then it makes a lot of sense to have a swappable battery. So we, for now, coexist next to each other. Since we're not directly manufacturing bikes, we're not directly competing. But of course, if everyone was to use an internal battery, that would limit the vehicles that we're compatible with to mopeds, kick scooters, and cargo bikes. Yeah, thanks everyone. I think those were all the questions. Connect with me on LinkedIn if you want to. I'm really happy to connect, and have a nice morning and evening. Bye-bye.